your note packet, page 7. All right. On page 7, you see our two special rate triangles. We have our 45, 45, 90, and then we have our 30, 60, 90. Okay? So now I want you to assume that our hypotenuse is 1. Okay? I want you to assume and jot down that our hypotenuse is 1. So knowing what our hypotenuse is, can you find the two side lengths of 45, 45, 90? And the two side lengths of 30, 60, 90? Can we find those side lengths out, knowing that our hypotenuse is 1? Yes? Go ahead. If our hypotenuse is 1, what is that equal to? X or x root 2? X root 2. Okay? So in order to solve for x, we have to do what? Divide by root 2, and then do what? So you have 1 over root 2. Yep. Good. You multiply root 2 by top and bottom. So both of our side lengths are root 2 over 2. Okay, which a lot of you did have, so nice job. Okay, now we move on to our 30, 60, 90. Yeah. And then you're able to just multiply. Okay, it's the same thing. You are correct. Just multiply those guys together. All right. So for 30, 60, 90, our hypotenuse is what? X root 3, or 2x? Yeah, you. 2x. So we have 1 equal to 2x. All right. Across from 30 is what? Thanks, Andrew. Yeah, 1/2. Good. Across from 60 would be what, Brian? Good. Root 3 over 2. Some of you had 1/2 times root 3, which is the same thing. Just multiply those numerators together, because that's the same thing as 1/2 times root 3 over 1, and you could just multiply across. Okay? Everyone okay? All right. So now we have the sides of our triangles figured out. We're going to apply our trig ratios. So, sine of 45. I could choose whatever angle, because they're both 45. But say if I choose this one. What is the sine of 45? Rory? Root 2 over 2. Opposite over hypotenuse, which is 1, is just root 2 over 2. What is the cosine of 45? Using the same angle. You? Yep, the same thing. Root 2 over 2. Adjacent over hypotenuse. Okay, we should write this down. Now we move over to the 30, 60, 90. Okay, the sine of 30 would be what? John? 1/2. Good. What would be the cosine of 30? Laurel? Good. Root 3 over 2. Good. Now if I move to 60, okay, what is the sine of 60? Abigail? Good. Root 3 over 2. And what is the cosine of 60? Andrew? 1/2. Good. Excellent. All right. So, knowing these values are the most important. Okay? Knowing these two triangles and those values are the most important to help us with trig. Okay? So we are going to dive deeper using these values today, okay? Today, we are learning about the unit circle, okay? It's a helpful way to find trig ratios for angles and multiple of angles of 30, 45, and 60, okay? So those values up above, you are going to need to know, okay? Like the back of your hand, you're going to need to know those, okay? The unit circle, okay? Think of a circle. A circle is how many degrees? 360. We have a center, and then what do we have? What's that line that goes across the center? The radius. The full line is the diameter. But we have the radius, right? Okay. If it's on the coordinate plane, we have a radius of 1. Okay. So we have the coordinate plane, and the circle is here, and then we have the center. Therefore, if we draw triangles, our hypotenuse is going to be 1. Okay? Hence is why we did those two triangles above with our hypotenuse 1. So now, when we work with triangles, we use the Pythagorean theorem, which, as a recall, knowing that a squared plus b squared equals our c squared, which is our hypotenuse. Okay? But now that we're going to take our triangles and write them on the coordinate plane, we are replacing A and B with what? Good, X and Y. And now our C value is going to be R, which is our radius. Okay, so we are rewriting our Pythagorean theorem as x squared plus y squared equals r squared, which is an equation of a circle. Okay, the equation of the unit circle, x squared plus y squared equals r squared, where the center does not change, 0, 0, and the radius remains the same as 1. Okay, so in geometry, you move the center around. Okay, your radius has changed. With the unit circle, it's staying at 0, 0, and your radius will still be 1 around. Okay, this next part, okay, I've been using colors with this, okay, 3 different colors to help us remember, okay. So, if you have your own 3 colors that you would like to use, they could be colored pencils, pens, okay, highlighters, markers I would be careful with because they kind of go through, but if you have them, you could use them. If you do not have your own, I have colored pencils up here. So I'm going to call you up by rows because this is a pretty big class. Hold on one second. Andrew's row, come on up. 3 different colors, okay, to recap what we just did, okay. So you have your 3 triangles here. However, now we have 30, 45, and 60. They're separate, okay. So remember, your hypotenuse for all of them was 1, okay. For 45, 45, 90, both side lengths were what? The same, which was what measurement, right? Root 2 over 2. Okay? Then, for 30, 60, 90, across from 30 was what value? What did we find out? What was our value across from 30? Yeah. 1/2. And then across from 60 was what? Good. Root 3 over 2. So we have our 30, our 45. Now we have our 60, which is going to be similar to this guy. However, across from 60, what value would this be? Yeah, Laura. Good. Root 3 over 2. And across from 30 is our 1/2. Okay? So that's what I just wanted to get down on the paper right now. We are going to, when we get back from lunch, use our colors. Okay? 45, and 60. So now with your colors, okay, with your colors, I want you to choose one color for 30, one color for 45, and one color for 60. So for now, you're going to take your highlighter or color and just outline the triangle in that color. Okay, so pick a color for 30, pick another color for 45, and another color for 60. Okay? Okay, so you want to highlight those colors. So for me, the blue is going to be my 30 degrees, green is 45, 60 is pink or purple. All right, so we're going to do the same thing. Here are our special rates as is. Now we're going to see how they look on the coordinate plane. So I'm going to take my same color for 30 and outline this triangle, as well as label this 30 and label the side lengths. Okay, so same color as what you have above. This is what it looks like on the coordinate plane. Okay, label your side lengths just like this. So basically, if we had a cut and paste, we would cut this out and put it right here. Okay, we're going to do the same thing for 45 and 60. Okay. Here is 45. We're going to label root 2 over 2, root 2 over 2. Right? We're going to do the same thing for 60, and you want your colors to be consistent throughout. Okay? So this is what it should look like if we were going to copy and paste. That's pretty much what we're doing right now. All right? All right. So now, we're going to be a little more specific. We're going to take away these two side lengths. So, same color for 30. And we're just drawing that line. Okay, we're taking away our height and our length across. Okay? And I want you to think of something. Knowing this is 30 degrees, knowing these are my side lengths, if I wanted to know this point using those side lengths, how would I do that? How can I use these and create a point? What do we think? What is an ordered pair made up of? Yeah, Josh. So an X and Y coordinate. Okay. Charlotte? Okay. You can, we don't have to square anything. Okay. So I want you to keep, we don't have to do any algebra here. Okay. To create our point. Yeah, Josh. Why? Excellent. Okay. So all we just did is the length from here to here. Think of your axes, X and Y. Horizontally, what is that? X. So we have root 3 over 2. And then vertically is our height, which is what? 1/2, right, is our y. So we remove those two side lengths, okay, to create just this line here. And the point is root 3 over 2 and 1/2, the coordinate point, okay? We're going to do the same thing for 45 and 60. So here's 45. What would my coordinate point be, my x and y for 45? John? Say that again. You could do it. Come on. Look at the triangle right above it. Yep. Perfect. Good. It's a tongue twister for that one. Root 3 you said at one point. Yeah. It's okay. All right. So now we're going to do the same thing for 60. All right. What would that coordinate point be then? What would my x and y be? Josh, go ahead. Good. Root 3 over 2. Good job, you guys. Okay. So this is what it looks like individually. Okay. That's what it looks like individually. So now we're going to tie those three pieces together to almost create our first quadrant. Okay, so you're going to do the same thing, however, all on one graph. Okay, so starting with our 30, then 45, so we have 30, and I'm just going to write what degree it is right above it. Okay, it's not ideal, but just yeah. Root 3 over 2 and 1/2. Okay. So this is what it looks like all together as you guys are piecing it together. Okay. Okay. All ordered pairs are written as x and y, and all of our ordered pairs in quadrant 1 are what? Positive, negative, what do we got? Positive, okay? So both are positive. Okay, well, there's still a few things we need to figure out. We haven't completed quadrant 1 because we have two bookends here, okay? We have these two lines we haven't even talked about yet, okay? What did those two yellow lines create just now? 90-degree angle. So would that be this degree then? Like if I drew it here, is that 90? Yeah, okay. So therefore, what would this be? Not 90, it's just by itself. So what would it be? Not 180. 0. Right? Because we're not moving up or down or anything. 0, then 30, then 45, 60, 90 to create a 90-degree angle. Now, another question is, well, what are those coordinates? I'll give you guys a minute. 1 second. Give you a minute. What do you think? Campbell? Why? Because the radius is 1, right? So this would be 1, 0, because our radius is 1, but we have no height, right? What would 90 be, Brian? Not 0, 90. 90 is just the degree. 1. 0, 1. Because we now are flush with this, okay? We have our y-intercept and we have our x-intercept because our radius is 1 all the way around, okay? So the x and y-intercepts are at 0 degrees and 90 degrees. The coordinates of 0 are 1, 0, which is our x-intercept, and 90 is 0, 1, which is our y-intercept. Okay. Quadrant 1 includes angles 30, 45, and 60. 0 and 90 are not included in a quadrant. They're called quadrantal angles. They're on their own, basically. Okay, but quadrant 1 is from 0 to 90, with 0 and 90 not included as in quadrant 1. Okay, so as we move into quadrant 2, what might be different? Josh? Quadrant 2, x values, right? Because when we're doing, anytime we're talking about quadrant 1, 2, 3, and 4, goes counterclockwise. Okay? So quadrant 1, quadrant 2. So you are correct. Quadrant 2, x is negative, y is positive. Okay? We know that already. So what I want you to do right now is do exactly what we did in quadrant 1. Okay? So just redo what we just did in quadrant 1 using your colors. Make sure you write in the degrees. And your coordinates. So as you guys are working, a full circle again is how many degrees? 360, right? All right. So what would half a circle be in terms of degrees? Yeah. 180. Okay. So what would be our new x-intercept then? Andrew? Good. Negative 1, 0. All right. So our new x-intercept is 180 at negative 1, 0. Okay. So we know negative x, positive y. Well, how can I figure out how to fill this out? What do I do, Brian? So what do you mean? So like for like this line, right? Which one? You tell me. What do you think? Okay. Okay, John? What's your first thought? This one? Here? Okay. You are correct in terms of degrees. Excellent. Okay. So, knowing that, how can I figure out what the coordinates would be, though? My xy. Josh?
Set 90 degrees as your angle, and then solve that's 30 degrees.
Careful. You which tends to happen. Phoebes? Okay. So how do I know which one goes where, though? You guys are doing an amazing, amazing, amazing job. And some of you are kind of thinking it, just don't know how to formulate it. Charlotte?
Like what he was saying, that like the 30-degree one, like at the top,
Okay.
and then like, because if you like flip the whole thing, then it's like the same. But I don't know if I'm like.
Okay, it's okay. Andrew?
Isn't it just the same thing? Like if you just reflected the other side over the negative side, just the x.
So going with that, okay, this line here, what would that coordinate be? Yes, that is correct. Okay, so Josh, in terms of where you said 90 was your new zero, there you go, reflect across the y. So all of you guys were amazing with that, by the way. These are similar angles, okay? So we have, John actually already figured out what the degrees are, okay? So this angle and this angle are the same. However, what Andrew said, it's negative root 3 over 2 and 1/2, okay? Here, 45, these would be the same, just a negative x. These would be the same, however, negative 1/2. Your 180 is your new zero if you want to look at it that way. You're always using the x-axis, not the y. Okay? So let's finish highlighting here. Okay. So I'm going to fill in the degrees what John said. 120, 135, and 150. And then go ahead with Andrew said. So John figured out, as you guys are writing this down, John figured out another way to figure out the degrees. Okay? Can anyone say if the degrees weren't there? Knowing what the similar angles are, can you figure out another way to find what those degrees are? I know now that we know that, so it's hard to like undo it. But if 180 is like your new zero, so to speak, yeah. Yeah, so we could have taken, if we didn't figure out a pattern, we could do 180 minus 30, 180 minus 45, 180 minus 60, because they are the similar triangles, okay? Or you could also notice that 30 degrees here and 15 in between, okay? That's another way, which I think you did as well, all right? So when you're finding out quadrant 2 or the rest, you are always referring back to quadrant 1. There's no other algebra happening right now. Okay? You're going to see a lot of similarities as we go through. However, matching them correctly is half the battle. Okay? So, if we look at, so the angle measures, you could figure out the 30 or the 15 in between, or take 180 minus either 30, 45, or 60. Okay? How do we find the coordinates? Well, we know it's a negative x and negative y and positive y. based on similar angles. Okay? So now, what will happen in quadrant 3? Yeah, Josh?
Reflected across both axes.
Okay, so both x and y are going to be what? Negative. Okay, so in quadrant 3, I'm just jotting this down right now. Negative x, negative y. Okay, what I want you to fill out is 1 and 2. If you feel really confident enough to do quadrant 3 on your own, go ahead. But we will be going through it together. Okay? So do 1 and 2 definitely from what we just did above. And then if you feel confident, do quadrant 3. All right? We are going to do it together though. Yep. All right. Can anyone tell me what my new y-intercept would be? Wow, Josh. Okay, go ahead. 0, negative 1. Anyone else can tell me what degree that would be? Sam? 270. Good. Okay. If you add to 180 and add 90, that's what you get. Okay. So, here we go. Got it already? What would, or how can we tell, what would this first line be? Blue, green, or pink? Andrew? Careful. Abigail. It would be blue. Okay? It would be blue. Because if you go from left to right, Andrew, 1 to 3, if you were to drag finger across, it would be the same. Okay? The middle one, always 45. Last one is 60. So, let me go through this. All right. So we know they have the same coordinates as quadrant 1. However, they're both negative. So just jot those down. What are my degrees in quadrant 3? Sam? Good? Good. Okay, from here, again, still using the x-axis, knowing this is blue, 180 plus 30, 210, 180 plus 225, plus 45 is 225. 180 plus 60 is 240. Okay? Do you guys see that? All right, so to find the angles, it's 180 plus either 30, 45, or 60. But again, you're always referring back to quadrant 1. Okay? Your coordinates are both negative x, negative y. Okay? The y-intercept is 0, negative 1, and that is at 270. Right? And then the final piece. Josh.
Where did I get the information?
No, not angle measure. Just tell me what's happening in quadrant 4. Okay. So what does that mean in terms of x and y? Thank you. Quadrant 4, positive x, negative y. So go ahead and fill out 1, 2, and 3. Right? If you want to give 4 a try, give 4 a try. So a full circle has how many degrees? 360. So 0 and 360 would have the same coordinate point. Okay? 0 and 360 would have the same coordinate point. So, I'll give you guys a minute. What would, okay, if I had to label these 3 lines, 1, 2, and 3, which one would be blue? Which one would be green? Which one would be pink? John? Good. 1 would be blue. Excellent. Okay. Next one would be green. And then pink. Okay. In quadrant 4 especially, I see a lot of flipping of the, even though the degrees are correct, the coordinates, a lot of people tend to flip those coordinates around, okay? So, you want to keep them the same, however, your y is negative. So you, oopsie. So you have root 3 over 2 and negative 1/2, root 2 over 2 and negative root 2 over 2, and then 1/2 and negative root 3 over 2. Okay. So the last thing is to fill out the degrees. What would be the pink? What degree would that be? Or what would be the blue? You tell me. Campbell? Good. What would the green be? Josh? Good. And blue? Brian? 330. And again here, you could have used 360, not 270, 360. 360 minus 30, 360 minus 345, 360 minus 60. Okay? You always want to go from the x-axis, not the y. All right? So, how can we find the angle measures? It's 360 minus either 30, 45, or 60. Remember the coordinates are positive x and negative y. Okay? So you guys just completed the unit circle. Completely. Okay? You will be given a unit circle every single class period to fill out. Okay? I know, hands tired. I know. This is my 6th one doing. Not in one day, but just the 3rd one in a row today. Filling out the unit circle. It's a lot. It's a lot, right? Give your hand a break, shake it out. So with the unit circle, you guys will discover certain tricks, okay? Certain tricks to help you, okay? Figure this out. I'm not going to tell you any right away. I want you to see if you come up with any tricks to remember, okay? There is one method you could use, which is at the bottom of your screen. You could create a bow tie for each. So, if you look at your blues, from the center, out and down, they're the same. From the center green, out and down, they're the same. Okay? However, you just have to remember, the coordinates will be the same, just different values. You will need to fill out a unit circle by degrees, by the coordinates, and eventually, we will be looking at radians, which will include pi around the unit circle. Okay? So there's one last thing. You guys are doing great. Okay? This is 12, I think. Page 12. One last thing. This is very simple to actually make you think. Okay. So just to recall, sine is opposite over hypotenuse, cosine adjacent over hypotenuse, tangent opposite over adjacent. So now I want you to think of, in terms of x and y, the side opposite from any central angle, so from the center, when it moves out, the side opposite represents the height of the circle at that location. What will that be known as in terms of x and y? Sam? Y. Okay, it's our y value. The side adjacent from any central angle represents the width, or the horizontal space would be the what? X. Good. The hypotenuse of the triangle in the unit circle now represents the radius. So that's dealing with R. Okay? So if I was to rewrite this as, instead of opposite over hypotenuse, using these values now, what would it be? Brian. Good. Y over R. What would cosine be? Abigail? Good. And now tangent. Brian? Y over X. So, we went through SOHCAHTOA. Now we're looking at the unit circle. Okay, just quickly. If we were given the cosine of 30, What would that be according to this? Cosine of 30. Right. Root 3 over 2. What would this, excuse me, sine of 30 be? Abigail? 1/2. Okay. So knowing these guys above, right? If I look at the unit circle, cosine of 30 is what? What's the cosine of 30? X or Y? X. It's root 3 over 2. That's my X value. What is the sine of 30? Please? 1/2. Good. Which is your Y. Okay? So, this is what we're getting into in terms of exact values. Okay? We didn't get too far. However, there's two things I want you to try. Okay? First one, on page 11, is a blank unit circle entirely. Okay? Try to do it from memory if you can. Okay? Especially that first quadrant. Okay? Another piece I want you to try. If you get stuck, don't worry about it. Okay? There won't be an answer key because we're going to go over these in class. Page 13. A through J. Okay, that's it. That's all your homework is. Okay? Page 11, blank unit circle.